Okay, so now let's have a look at example 4. Example 4 says, describe the shape of the curve y equals x cubed minus 3x squared at the point where x is 2 and when x is negative 2. So describing the shape, it's asking us to say, is it a concave up or is it concave down at those particular points? So we need to use our second derivatives to check is the rate of change of our gradients positive or negative to define whether our curve is concave up or concave down. And then part B, it says work out the coordinates, the points of inflection of our curve. So let's do part A. Oops, wrong pen. Okay, blue pen. So part A, we've got our function y equals x cubed minus 3x squared. So to check the shape, the concavity, we need the second derivative. So we need to first find the first derivative. So y dash gives us 3x squared minus 6x, just taking the derivative of the y function. Then we need to look at the second derivative. So differentiate 3x squared minus 6x gives us 6x minus 6. So we can use the second derivative function to check the concavity of our points. So part 1 says when x is equal to 2. Well, what's the y dash dash, the second derivative value at x equals to 2? So wherever x occurs, you put in the number 2. So that's 12 minus 6, which is 6. 6 is positive. So going back up to our definition, if our second derivative is positive, then we have a concave up or a convex shape. So therefore, curve is concave up, or in other words, convex at the point x equals 2. Part 2, we're doing the same thing, but when x equals negative 2. So the second derivative at x equals negative 2, wherever x occurs, replace it with a negative 2. So that's minus 12 minus 6, which gives us a negative 18. Negative 18 is negative. So going by definition, if our second derivative is negative, our curve is concave down. Concave down at x equals negative 2. So checking the shape or the concavity of a curve, you're looking at the second derivative, looking at how the gradient changes. If the gradient is increasing, then the second derivative, the rate of change of the gradient is positive, versus if our gradient is decreasing, then the rate of change of the gradient is negative. And so part B, let's do it over the page for more space. We're trying to find the point of inflection. So remember the definition of a point of inflection. Point of inflection occurs when your second derivative equals 0. So point of inflection when y dash dash equals to 0 and concavity changes either side. So it has to satisfy those two conditions. So concavity changes either side of that point of inflection. So we want y dash dash. So what was y dash dash equal to again? Y dash dash was 6x minus 6. So y dash dash equals 6x minus 6. So 0 equals 6x minus 6. So solving for x, we have 6x equals to 6. So x is 1. So at the point x equals 1, we need to check the concavity on either side of x equals 1. So let's check concavity on either side. So drawing up a little table. So we're looking at the left and right values of x equals 1. A little bit left, a little bit right. We're checking for the y dash dash values, not the gradient values, but the second derivative values. So we're checking when x equals 1, and then a little bit left, let's say 1 minus 0.1, which is 0.9, and a little bit to the right, which is 1.1 as well. So the y dash dash at the point 1, so y dash dash is 6 times 1 minus 6, which is 0, which is good. Otherwise, it wouldn't be called a point of inflection anyway. So y dash dash at 0.9, so 6 times 0.9 minus 6. Using a calculator, what that gives me, 6 times 0.9 minus 6, whoops, hang on, 6 times 0.9 minus 6 gives me negative 0.6, which is negative. And then y dash dash at 1.1, so 6 times 1.1 minus 6. So that gets me 0.6, which is positive, and that's good because that tells us concavity changes on either side. So we're going to write that statement down. So let me just draw a line. So move that across there. Okay. So therefore, concavity has changed either side of x equals 1. So that's good because that tells us x equals 1 is the point of inflection, because that's the point when y dash dash is equal to 0, and that the concavity changes on either side of x equals 1. Now remember, the question asked us to find the point of inflection. We've got the x value, we need to find the y value of that point. So when x equals 1, what's the y value? Y equals 1, well, x cubed, so 1 cubed minus 2 lots of x, sorry, 3 lots of x squared. That was the function, wasn't it? X cubed minus 3x squared. Yep, so that's 1 cubed minus 3 times 1 squared, which gives us negative 2. So we can say, therefore, the point of inflection, and there's only one, is 1 comma negative 2. Obviously, you can always check with a sketch. Check with a sketch whether you want to sketch it out physically by hand, you're using our derivative methods, which we'll actually look at a bit more in detail next lesson. Or we could go use a graphics calculator to check it. I don't have a graphics calculator, so I'm going to use Desmos. Find Desmos. We wanted to sketch y equals x to the power of 3 minus 3x squared. Yep. So if you look at the graph here, we've got a stationary point at 0, 0. We've got a turning point at 2, negative 4. Let me see if I can screenshot that. Okay. And then back here, put it in here. So insert a picture. Oh, can fit. I'll make it fit. I'll make it fit. I wonder if I can crop this. That's alright. So you'll see here we've got a turning, we've got 2 stationary points here and here, right? At x equals 1, that's down here, this is the point of inflection because this is a concave down at that maximum sad face turning point, whereas over here we've got a happy face minimum turning point, and then the point where our concavity changes, that is our point of inflection. That's what part B was talking about. So we were trying to solve for this point of inflection where the rate of change of the gradient, right, is equal to 0. Now for part A, we were looking at the shape of the curve at x equals 2 and x equals negative 2. So you could see that x equals 2, our graph was a concave up, which is what we agreed on when we did our maths. The y dash dash is positive, and then if you looked at what x equals negative 2, which is down here, the curve was a going downward, so that was the concave down, so that's why our y dash dash was negative.